Let's move into our new unit on systems of linear equations. We're going to be focusing on systems of linear equations in two variable, and we're going to limit it to just two linear equations. However, you could have a system with more than two equations as well as more than two variables. With a system of equations, we're graphing them on a same coordinate grid, and we're looking for a common intersection point. And the point where those two lines cross is called the solution to a system. More formally, it's any point that is a solution to all the equations in the system. And we can represent them in a few different ways. And in business, often we use linear equations as well as in other scenarios to model multiple events. And if we have a crossover point, then that is going to be the solution to the system, which usually identifies important information. Such as with business, if we have one equation modeling cost as we produce something over time, as well as revenue as we make and sell those things, eventually there will be a point where the amount of money we've made is more than the amount of money that we've spent. And that's called a break-even point. And that tells us the turning point of where we end up having profit. And profit is the difference between the cost and the revenue after that point. So the first thing we're going to look at is determining whether or not a solution or an ordered pair is a solution. Well, in order for an ordered pair to be a solution to an equation, it has to be on that line. In order for an ordered pair to be a solution to the system, it has to be a point on both lines. So we test to see if this given point is on both of these lines by substituting it into the equations. If we get a true result, then it means that it is a solution. If we get a false result, then it is not a solution. So when we simplify the left equation, we see that we have a true solution. When we simplify the right equation, we see we have a true solution, meaning that, yes, the point -1, 1 is a solution. And likely the only solution, but not guaranteed. We'll try it again with B. We want to substitute our ordered pair into both of our equations. When we simplify the first, we see that we get a true statement. But when we simplify the right side, we get a false statement. And since it's not a solution to both equations, then it means that the point is not a solution.